Question 3. Suppose you pick up a 16-gram ball of iron, such as a shot put ball, at a track event. Now the iron ball has the same temperature as the atmosphere on a cool day, 16 degrees Celsius. Calculate the amount of heat energy that the iron ball must absorb to reach a temperature of your body, 37 degrees Celsius. Suppose you pick up a 16 grams ball of iron. So take note of the data there. So 16 grams of ball of iron. Okay. You are picking up that. Okay. And then the iron ball, we are told the specific heat capacity is 0.451 joules per gram degrees Celsius. As the same temperature as the atmosphere on a cool day. So the temperature of that iron ball is that of the atmosphere, which is 16 degrees Celsius. Now calculate the amount of heat energy that the iron ball must absorb to reach the temperature of the body. So this lies in the fact that if two things are to be in contact, they are supposed to head to a place where the temperature becomes the same. Okay, so if you combine even water, right, this applies even to liquids as well. If you get water at 40 degrees Celsius, you combine it with water at 75 degrees Celsius, the final temperature is going to be in between. Okay, so they want to reach an equilibrium temperature. So even you, when you get to hold the iron ball, you pick it up, your body temperature is 37 degrees Celsius. The initial temperature of the iron ball is 16 degrees Celsius. So the final temperature should be what? Should be in the middle. Okay? So for that to happen, energy is supposed to be lost from the high temperature, which is 37, to the lower one. Okay, so that's why they are saying calculate the amount of heat energy that the iron ball must absorb. So the formula that you should always think of when you see such questions, think of mcat. M, specific heat capacity, change in the temperature. Okay. So our Q, which represents the heat energy, is going to be, our M is what? Our M is the mass, 16 grams of the iron ball. Specific heat capacity is 0.451 joules per gram degree Celsius. And then multiply by the change in temperature. The final one, what is the final one? This is now where you have to be okay. Calculate the amount of heat energy that the iron ball must absorb to reach the temperature of your body, 37 degrees Celsius. Okay, so what must happen? That means that its final one is 37. Then the initial should be what? 16. This is degrees Celsius. So degrees Celsius will actually divide. The grams will equally divide. So we just remain with the joules there. Okay, so our Q therefore becomes 16 multiplied by 0.451 times 37 minus 16. That should be able to give us the energy that must be absorbed in this case. So what I'm getting 151.4 joules. This is the amount of energy that the iron ball must gain or must absorb for it to reach to that temperature of your body. This is only because, why is it so? This is because the temperature of the body shouldn't change, right? So it's constant, so the iron ball has to adjust. Now if you go look at B, it's a similar question. A sample of platinum metal weighing 18.7 grams experiences a temperature rise of 2.30 degrees Celsius when 5.70 joules of heat is applied. What is the specific heat capacity of platinum? So we've got platinum metal, which is weighing 18.7 grams. It experiences a temperature rise of, so when you see a rise or a change, just know that that's representing the delta T. Okay, And then when 5 points, so this is energy, right? So that's your Q. When 5.70 joules of it is applied, what is the specific heat capacity? So you can actually see that if you look at the formula, mcat, you take this to be your S so that you're able to remember the formula easily. Okay, so if you try to make specific heat capacity as a subject of formula, you have to divide by m and delta T. Okay, so our specific capacity, our energy, heat energy is 5.70 joules. Our mass is 8.7 grams. Our change in temperature was 2.3 degrees Celsius. Okay, and then that is on top, that is in joules. Okay, so 5.70 divided by a product of 18.7 times 2.30, that should give us our specific capacity. So I'm getting 0.131 joules on top per gram multiplied by degrees Celsius. Okay, so what is the specific heat capacity of platinum?